So today we're going to be focusing on how to apply a rational equation to solving a problem. So we're going to start with a little bit of a thinker question. We're going to think here about if we had 1,000 cookie dough truffles, and we're going to bag them all in individual bags. So like we want to hand them out one at a time. So we're going to put each one in its own little bag. So here's some information for you. To start, I have some intel about 3 different people. Jack can bag 20 truffles every 5 minutes. Ben could bag 35 truffles every 7 minutes. And Sam could do 42 truffles every 6 minutes. So let's think about if I brought them in and said, all right, I want you to do the job. So like Jack says, oh, no worries, I'll come in and take care of this job for you. How long would it take Jack to bag all 1,000 truffles? Well, let's think about that. If he can do 20 truffles every 5 minutes, if I want to answer that question, what would I likely want to know? If I'm going to figure out how long it takes, I'm pretty sure the first thing you're going to calculate is how fast he can work. You're probably going to get a rate. How many truffles per minute can Jack bag? Well, if he can do 20 truffles in 5 minutes, then he can do 4 truffles in 1 minute. If he can do 4 truffles in 1 minute, then 1,000 truffles divided by 4 per minute means it would take Jack 250 minutes in order to do the job alone. All right, by that same logic, go ahead and calculate for Ben and Sam. Pause the video real quick while you do it. Okay, so we're back. And so Ben can do this at 5 per minute. He's a little faster. So he could get the job done in 200 minutes. And Sam is our speed demon and can get it done at 7 per minute. And so could get the whole job done in just under 2.5 hours. Now, maybe that's not fast enough. Even Sam at speedy 2.5 hours, maybe I need it done faster. And we all know if you want a job done faster, you don't have one person do it. You have them do it together. So what if I had all 3 come in? And I'm like, okay, well, why don't all 3 of you come in together? If they all came in together, how fast would they be able to get the job done? Pause and see if you can figure that out. Welcome back. Now, I'm assuming you didn't just add these up, because if they are all working together, it's not like I'd add together their times. That would make no sense. So I'm going to note that. You can't just add together their time. They're working together. But what about this? Can I add together their rate? If Jack is bagging 4 truffles every minute, Ben's doing 5 every minute, and Sam's doing 7 every minute, then can I add that together and say that every minute the 3 of them are bagging together, 16 truffles in every minute are getting bagged? That makes sense because the 3 of them are grabbing truffles from the pile. So yeah, side by side, each one doing their load, that's how many are getting done. So then if I come over here and divide that out, looks like if all 3 were working, it would get done in a little over an hour. That makes sense. Hence the phrase, many hands make light work. If you put together all 3 of them, it should get done faster than even the fastest can do alone. And if we think about that, how do we get the rate? Well, the rate, no matter what you do in any situation, is always the job you need to do divided by the time. Now, if you think rate like speed, well, there the job is a distance. But a rate is always the job you need to do divided by the time. Now, that's great. We can figure this out with a table and everything. But what does this look like if we tried to do an equation? Because, that's what we're talking about. So if all three work together simultaneously, side by side, how long would it take to get all 1,000 truffles bagged? So here we go. X is going to stand for the thing we need to know, and that is how long would it take to get them all bagged working together. So let's let X be the time together. Now, in this problem, we noticed we can't add the job. We can't add the time, but we can add rates. So that means that I can add Jack's rate, and I can add Ben's rate, and I can add Sam's rate, and that's going to give me a together rate. This is what I'm allowed to do. Now, in every case, I know that rate is job divided by time. So I need to go back and look and see what is the job divided by the time. So I'm going to color code here because that's what I do. So we'll make Jack and make Sam, Ben, and together. So if I look at Jack, job over time for Jack is 20 truffles in 5 minutes. Now, of course, we got to make sure the time is the same for everybody, or the unit. So in this case, minutes. Ben's job is 35 truffles, because that's the job here, is truffle bagging. And his time was 7 minutes. If I go to Sam, the job is 42 truffles, and the time is 6 minutes. And if I now go to the together, it's way up here, but here's my together information. It's that 1,000 truffles. So it's 1,000 truffles, and I don't know how much time it takes. So there it is. I've matched everybody to a job and a time. Now I'm ready to solve. So I find my LCD. Between 5, 7, 6, and X, the LCD is 210X. 5 times 7 times 6 times X. So now I go through and I take care of everything. This 5 is missing a 7, a 6, and an X. So that's 20 times 7 times 6 times X. This 35 is missing the 5, the 6, and the X. And this 42 is missing the 5, the 7, and the X. And this 1,000 is missing the 5, the 7, and the 6. LCD, LCD. So now let's go ahead and multiply everybody out. So that's 840X plus 1470X plus 1050X equals 210,000. And if I add my X's, I'm going to come up here because I ran out of space. That's 3360X equals 21,000. And now if I divide out that 3360, I get 62.5 minutes. So I get the same answer. And that's really not the point. Remember, the point here is that what you're learning to do is model the problem with the equation and then be able to solve it. Because sometimes these problems would not be easy to figure out the way this one was. So knowing how to set up the equation is the key. We use this easier problem so that you can see how what makes sense number-wise also makes sense equation-wise. So give problem number 2 a shot. See if you can set this one up. Work through it. See if you can set up an equation. And then when you're done, restart the video and see how successful you were. Hey, welcome back. So Jimena and Lana are filling up their backyard swimming pool for the summer season using a big diameter hose from the back of their house and then a smaller diameter hose from the side of the house. Last summer, those two hoses running together filled the pool in 9 hours. And then having experimented with these hoses before, they know the smaller one takes 3 times as long as the larger one. And so they're going along and, oh no, when they get out the hoses this year, the smaller one's been chewed up by mice, darn mice. How long will it take their pool to fill up if they only have the larger hose? Dang. So let's go through and find information. So I've got Jimena, and why don't we say that Jimena's in charge of the big hose. So big hose. And we know smaller is 3 times as long as the big. So there's the big. All right. So now we'll let Lana be in charge of the little one. All right, that's a together. Smaller is 3 times as long as the bigger one. All right. But we know the smaller one's been chewed up by the mice. And what do we know here? Together, they can do it in 9 hours. And we have a swimming pool. And all right, so let's see what we've got here. How long will it take to fill up the pool using only the larger hose? All right, so let's let X be the time for the big one. So now let's map this out. We have the rate for the big hose. We have the rate for the small hose. And we have the rate of them working together. We know that the 2 individuals together would work at a speed equal if we added them. Now let's see if we can put it all together. Job over time is rate. Now in this case, if we break it down, you'll notice there's no other number to represent the job. That's because the job is 1 pool. So the big hose can do 1 pool in X amount of time. The small hose can do 1 pool in 3 times as much as the other one. And together, they can do 1 pool in 9 hours. And so there's my equation. All I got to do now is LCD this thing and solve it. So what's my LCD? Let's see, that would be 9 because that's 3 times 3 and X. So this one is missing the 9. This one's missing a 3. And that one's just missing an X. Well, so now if I simplify, I just get that X is 12. And so I know the big one needs 12 hours. It's going to take a long time to fill that pool. And so there we go. We will continue working on these models when next we meet.